Welcome guys back to another video, and today we're going to be talking about the power rule, or essentially another way to find derivatives or the slopes of functions. But this time this is so much easier, and essentially because usually your calc teachers will teach you how to find the limit definition of a derivative first and have you go through the long way. But this is a short way. This is going to be like a very short video compared to my other ones. But this is a very simple way and should be the go-to method whenever you're finding a derivative of a function such as x squared, x to the third, x to the fourth, 5x squared, functions like that. So essentially, how the power rule works is if you have a function of any order, I would say, you have x, and then from here you would have x to the n of whatever, right? So from here, in order to make the power rule work, you would bring down the n and make it a constant multiplying the x, then you would subtract 1 from the exponent. And essentially that's all the power rule is. It's just another way to find the derivative. This time it's much easier and should be your go-to if you're taking college calculus, if you're unless your professor specifies you not to do it, then do it. Or unless you're taking AP calculus, any kind. This is very useful. And any situation where you're trying to find the derivative and it's, like in 5x squared, 10x, it's very useful. And we're going to see an example soon. So I feel like I remember one of my first examples was 2x. Was 2x is equal to f of x. Should I write that the other way? So I remember one of my first examples was f of x is equal to 2x. And then I said that the slope, or f prime of x, is equal to 2. Now, we were to do that through the power rule. All we would have to do is just put the 2x here, then just put a 1 over it, because technically x to the 1 is just x. And then all you have to do is just bring down the 1, multiply it, and then just subtract by 1. Then you just be left with 1 times 2, which is just 2, x to the 0. And we know that anything to the 0th power is just 1, so our slope would just be 1. And so that's a way that you can use the power rule in order to say that 2x and the slope for the function will be anywhere from, no, just 2. It would just be 2. And here's what I mean. So let's look at another example. Let's look at the function x squared, right? So, and we're going to draw out the graph. So this is the function x squared. Now, if you're already seeing a pattern, you might say, well, in order to find the derivative of x squared, we can just bring down the 2, multiply 2 by x, and then subtract the 1, and then you're left with 2x as your derivative. And our original function was x squared. And so the reason why that works is because you can see here that each time x squared, so let's look at the positive side, right? Or with the right side. Let's look at this side. You can see that any time the domain is more than 0, we can see that the slope will always be positive. Or at the very least 0, because you could always have 0. So let me just write down this. Yeah, that works. So each time you can see that the slope is increasing. And that makes sense because let's say this is 1 and then this is 2, right? Just imagine that's 1 and 2. We can see how the slope here, or the tangent line, so where the line just hits 1 point, it's that way, but when it's at 2, it's much steeper. You can see how it's much steeper. And so let's say you were to put, f prime of 1, which is essentially when you put a specific point into the derivative, you'll get 2, right? And then if you put f prime of 2, you'll get 4. And so these numbers are essentially saying that f prime of 1 is like 2 steep, while f prime of 2 is 4 steep. And so that's the slope at this specific point. It won't always be the same like linear functions, because linear functions are just linear. They always have a fixed slope at any point. But for these higher order derivatives, they're gonna have equations and functions that have different slopes at different points of the graph. And what do I mean by that? Well, let's look at another example. Let's look at x to the third, right? Just imagine that's a third. So x to the third. If you're paying attention, bring out the 3, subtract the 1, you'll see that the derivative is just 3x squared. And so that makes sense because if we're looking at the graph, it's kind of weird, right? But this is where it gets interesting. We can see here that the derivative of x to the 3 is just 3x squared, right? And what does that mean? So if you were good with algebra 2 or even like pre-algebra, you would know that if you were to put any number and square it, will always be positive. And so here we see how throughout the whole domain, the slope is always positive. It is never negative. We can see here that even when it's going down to negative infinity for the domain, we can see how it's always at least positive. It's always positive somewhere in the graph. It's always positive, except for 0 because it's just a flat line. But still, it's never negative. And that's a cool way to know whether your derivative is right or wrong. And so essentially for these, high order derivatives, you might want to, just remember like a parent graph, parent function, because 3x squared, any number you put in there, negative, positive, you always get a positive number out. And this makes sense when you look at the graph. So my final example would be 9x to the 3 minus 6x squared plus 9. So this is f of x. So I'll give you 5 seconds to find the derivative. 5, 4, 3, 2, 1, and this is the derivative answer. So f prime of x. So as long as you've been watching this video, you will be okay. So again, we bring down the 3 to multiply with the 9 because we always multiply the constants. And so 9 times 3 is 27. Subtract the 1, you'll get 27x squared as your first derivative. And since these derivatives are multiplied together, we'll get that to a later video. They're each separate. So think of them as separate functions, but they're still in the same function, like same function family basically. And then you go to the next derivative, you bring down the 2 to the 6. 6 times 2 is 12. And then you subtract the 1. So it'd just be negative 12x. And then this is the interesting part. Remember, if f of x or any function is a constant, f prime or the slope of that constant is always 0. And so here you could just put positive 0 if it doesn't make sense, but you just don't have to put anything there. And the reason why I say that, let's look at the graph of 9, for example. This is 9. So as you can see, a constant is just a horizontal function. The slope anywhere throughout that constant on the graph is just 0, as you can see, because it's just flat. Since it's just a flat line, therefore we can say that the constant derivative is just 0 because there is no slope. But it's not vertical as well, where you can say that it's undefined. It's just 0. So that's always a very, very important fact to remember. And so essentially, our derivative of 9x of 9x to the third minus 6x squared plus 9. F prime of x would just be 27x squared minus 12x plus 0 if you want to put that down if you're still confused. So I know I said that was going to be our last example, but I want to do an example with fractions. So f of x is equal to 1/4 x to the third plus 1/2 x squared plus 1/9 x to the 3. Actually, not x to the 3, just x. Let's just make that x. So I'll give you about 3 seconds to figure this out because you're just, repetition basing. And if you've been repeating some things and, you might find it easy, some might find it harder, it's okay. I'll give you 3 seconds. So 3, 2, 1. So f prime of x, bring down the 3. And remember, bring down the 3 means multiply the 1/4 times 3. Which just means that you multiply, it would just be 3/4. And that's essentially the same for any type of, like 2 times 1/3. It would just be 2/3, right? Subtract the 1. So your first derivative will be 3/4 x squared. Plus, bring down the 2. 2 times 1/2 is just 1. So, and then subtract the 1, you'll just get x. And then obviously, the last derivative would be 1/9. Because remember, this is like an divisible 1. And since 1 times, whatever number you're multiplying is just the same, and then subtract the 1, this is essentially just x to the 0. But again, anything to the 0 is just 1. So essentially, our f prime of x from our original function f of x, 1/4 x to the third plus 1/2 x squared plus 19x. And our derivative would be f prime of x is equal to 3/4 x squared plus x plus 1/9. And so that would be our last derivative answer. And so essentially, this is how this is just another simple way to find, derivatives. If you, because that's what I was saying, my last video, how I knew the derivative of this was going to be this, but, you didn't have the power rule. But essentially, it's just another fast way to find out derivatives really quick. Hopefully, y'all enjoyed the video. Please like, share, subscribe. For more content, please. Kind of need it. But that's been the end of the video. I really hope y'all liked it. And get to calculus working. Goodbye.